going to be. All right, so here we go. I want the fourth term. Has to be geometric, so a geometric sequence, right? Okay, so that's equal to 125. 10th term is equal to 125 over 64. I want the 14th term. So we know to find a sub 14. We're going to need to know what? First thing we need to figure out is what? What is R, right? Okay, so what's R? So we're given the fourth term and the 10th term. So I want you to think about this. If I'm at a sub 4 and I have a sub 5, 6, 7, 8, 9, and I have a sub 10. How many times, let's figure this out. A sub 10, I'm starting at a sub 4, it's going to be R to what power? How many times did I have to multiply? 1, 2, 3, 4, 5. So this is R to the 6th. So we can set this up and figure out what R is by plugging in the values we know, can't we? It's very ACT type questions here. They're not going to give you a sub 1 and R and tell you to find. That's an Algebra 1 skill. An pre-cal skill would be, here's the 4th term, here's the 10th term, now tell me what the 14th term is, where you have to go back through and look at and figure out what those values are. So let's fill in what we know. 10th term was what? 64. 4th term was, and we have R to the 6th. So first things first, what are we going to do? Can't we divide both sides by 125? So this becomes 1 over 64 equals R to the 6th. Would you agree? Okay, so how do I find R now? Yeah. Take the 6th root here and the 6th root here. This and this go away. So now R is equal to what? What is the 6th root of 64? Yeah. So R is 1/2. So now that we know R is 1/2, we can now take either a to the 4th or a to the 10th and figure out what a to the 14th is, doing the same thing we sort of did here, can't we? All right, so we had a to the 10th, and we're looking for what? 11th, 12th, 13th, and 14th, aren't we? So a to the 14th, starting at a to the 10th, we're multiplying by R, is going to be to what power? Figure it out. 1, 2, 3, 4. So this would be R to the 4th, wouldn't it? So this would be R to the 4th. Now, do we know a to the 10th? Do we know R? Then we can solve this problem. So we plug in. A to the 10th is 125 over 64. R is 1/2, and this is to the 4th power. So this would be what? 125 over 64 times 1 over, what is 2 to the 4th power? 2, 4, 8, 16, right? So a to the 14th is what? 125 over 1024. Let's look at another example. Anybody have any questions on that one? Why don't you guys try this one? A sub 2 is 6. A sub 5 is 81 over 4. I want to know A sub 8. Can you figure it out? Get the right answer? Not too bad, is it? Now, what if they give you A sub 1? Bonus makes it easy, doesn't it? What if they just give you the series or the sequence and ask you to find the 9th term or the 10th term? Okay, so let's do one more simple example. Let's say your geometric sequence is, oh, I don't know. And how do you tell if something's a geometric sequence? Yeah, if all of them are common multiples. Let's say I want to find the second term of, let's try actually, let's not make it the 32nd. That's really big. Let's make it the, I don't know, the 10th term. That's not terrible. All right, so what do I have to find to use my formula? Well, first term wouldn't hurt too, would it? So we need to know A sub 1. So what is A sub 1? The very first term, so it's 4. And how do I find my common ratio? Yeah, take the second number divided by the first number. 2 over 4, which reduces to, okay, so if I want to find A sub 10, that's going to be A sub 1 times R to the what? 9th. Okay. Have y'all figured out yet if you take this minus this, you get that? Every time. Okay. So 10 minus 1 is 9. Okay, so do we know a sub 1? We know r. So we can figure out what it is, can't we? Okay. All right, so now we need to move on to what is a geometric series. You can. Yeah. Yeah. That'll work. All right. So, geometric series. What's the difference between a geometric sequence and a geometric series? A geometric series is you take a sequence and you put plus signs in between or minus signs. It is simply adding up the terms. It's summing the terms of a sequence. All right? So that 2, 4, for example, that 2, 4, 8, whatever, would now be 2 plus 4 plus 8 plus 16 plus 32, and so on. This would be an infinite one. Do you know why it's infinite? That dot, dot, dot at the end means it just keeps going, doesn't it? We can have finite ones. We can have infinite ones. All right? Finite means it doesn't keep going, dot, dot, dot. It goes to a final number, doesn't it? Infinite means it just keeps on going. So what we typically do when we have this sort of thing is that we look at how do we sum it. That's usually what we're interested in, is what happens when we add all these things up. All right? That's kind of where it goes from here. So let's talk about finite versus infinite. Finite means it has a set number of terms or specific number of terms. Infinite means what? Yes. Infinite number of terms. And because it's added every time, you know what our notation is for finding the sum? Our notation for the sum if it is finite, we do S sub n, because that's telling us to add up the first n terms. Get it? So if I want S sub 8, S sub 4, that's the first 4 terms. S sub 50 would be the first 50 terms, and so on. Okay, that would be a finite sum. If it is an infinite sum, it's just S, capital S. Okay? We're going to delve more deeply into these after a while. So equations for a finite. S sub n. S sub n, the formula is, there's a couple different things. How much have you learned about summation notation? Just out of curiosity. Do you even know what summation notation is? Okay, so let's start with what the formulas are, and then we'll go kind of jog over into summation notation and what it means, okay? And how can we tell what that is? So the formula for the finite would be the sum of from, what am I doing here? I equals 1 to n of a sub 1 r to the n minus 1, right? That's the formula for each term, isn't it? A sub 1 n r to the n minus 1. That is equal to a sub 1 times 1 minus r to the n divided by 1 minus r. This is an important formula. Now, let's talk about what this summation formula means right here. This guy, the anatomy of this guy is as follows. This is called the index. This is where the index starts. Okay? And really, this should be, excuse me, hang on a second. I have given you a bad thing right here. If this is I, this would be I minus 1. So if this is I, that's where the index starts. This is where the index ends. Okay? And this right here is our term formula. By the way, this guy right here is called sigma, because you'll sometimes see summation notation or what we call sigma notation. Sigma simply means, so sometimes you'll see this as, this right here is either summation notation also known as sigma notation, okay? So you'll see it referred to both ways. Don't freak out if you see it. Now, infinite's a lot easier. That's the formula for the infinite sum. Much simpler. So finite, we need to know the first term. For infinite, we need to know the first term. For both of them, we need to know r, don't we? And the only difference otherwise is that for finite, we need to know how far we're going, which is n. Get it? So let's look at a couple of series, and we're going to look at them both written out, and we're going to look at some of them where they are in sigma notation, and we're going to figure out what is the either finite term or finite sum, the infinite sum, etc. Okay? All right, so here we go. So here's the easiest one. So the first thing you have to ask me, is this going to be a finite sum or an infinite sum? Why finite? Yeah, first 10 terms, right? So that is a finite amount. So we are going to be finding S sub what? Yeah. For the first 10 terms, it would be S sub 10. So what we know, that's what we're looking for. So we know n has to be 10, a sub 1 is 3, and r is 5. This is just a plug and chug, isn't it? So what's our formula? There's our formula, correct? So now let's plug in. Here we go. S sub 10. A sub 1 was what? So 1 minus, what's R? 5, right? And N is 10? So now we just have to figure out what that is. And this is a calculator problem at this point, guys. Work from the inside out. You're going to take 1 minus 5 raised to the 10th power, right? Divide that by -4, right? 1 minus 5. And then multiply that by 3. So what'd you get? $7,342,218. Okay, it's just a calculator problem, isn't it? It's not terrible stuff. Well, depends on how it's given to you. We're going to look at some more examples here. Anybody have any questions about this one so far? Okay, so now. So what are the things we need to know to plug into our formula? There's 3 things we need to know. 4 things, really. First thing we need to know is, are we doing a finite or an infinite? Finite. Why finite? First 5 terms tells me that it is finite, doesn't it? Cool. So what are the 3 things I need to know for a finite? Yeah. So we need to know a sub 1, we need to know n, we need to know r, don't we? So what is a sub 1? Right here, isn't it? It's 1. Now we need to know r. How do we find r? Take the second term and divide it by the... All right, so what is the second term? Divided by the first term. 0.7, isn't it? If we took the third term and divided by the second term, will we get the same thing? Yeah, then it's geometric. So we know it's geometric. We know r. And what is n? N is 5. Okay, so now we just plug in. S to the 5. S sub 5 is 1 times 1 minus 0.7 to the 5th divided by 1 minus 0.7. Calculator problem. Hang on a second. I got notation messed up here. All right. So here's your summation notation now. So, is this finite or infinite? How do we know it's finite? We could have this could be an infinite series. Here's how you tell. See right here? That tells you where it ends, doesn't it? It's starting at what term? First term and going to the 12th term. So if it starts at the first and goes to the 12th, it must be finite. If it's going to be infinite, guess what's up there? Instead of 12, what would it be? Infinity symbol. Yes, that would be an infinite sum, okay? All right, so it is finite. So for a finite, this right here tells me it's finite. So we need to know S sub what? S sub 12. Because N is 12. What is R? What is A sub 1? Nope. A sub 1, to find A sub 1, we are going to have to plug in what for N? This would be our first term, wouldn't it? So our first term would be 4 times 0.3 to the first, wouldn't it? So to find the first term, we plug in 1. To find the second term, we plug in 2. To find the third term, we plug in 3, and so on. Make sense? Okay. That would be what? 1.2. So A sub 1 is 1.2. Now, we also need R. Let me give you a hint. R is always what's being raised to the power. See that right there? This would be R. Because isn't that what we do to find it? We raise something to, we multiply, keep multiplying by that value over and over and over again. So R is 0.3. So now do we have everything we need to plug into this formula? We do, don't we? All right, so let's find S sub 12. (1.2) 1 minus 0.3 to the 12th power divided by 1 minus 0.3. And we could find this value, couldn't we? And I'm going to round just a little bit. So there's my value. Now, I'm going to double check this and actually do yeah, it doesn't have a, not fractional, is it? All right, any questions so far? What do you think? All right, so let's try another one. So now, what type of sequence or series, really it's a series, isn't it? Because it's not just a list of numbers, it's the summation tells us we're adding them, correct? So how do I find the sum of this series? Yep. We know it's infinite, number one, don't we? This tells me it's infinite, doesn't it? So S this time is what? Yep. A sub 1 over 1 minus R, correct? So now what do we need to find? A sub 1, we don't need n this time, do we? As a matter of fact, we don't have an n because we don't have a place to stop. So we need a sub 1, 4 times 0.6 to the first, which is going to be what? And we need R. What's R going to be in this, guys? Yep. 0.6. That would be my R, wouldn't it? All right, so we just plug in. 2.4 divided by 1 minus 0.6. All right, so here's a question for you. What if you get this? Is that sum going to be different than the other sum? This right here, you've got an extra term, don't you? Do we have an extra term? Big term, little term, do we know? It does. It makes a difference. It absolutely makes a difference. Where you start. What is your first term? There's a different first term for this, isn't it? Because the index starts at 0 and doesn't start at 1. The first term in this sequence, A sub 1, is going to be 4 times 0.6 to the 0. Do you understand why we plug in 0? That's the first number, that's the first index, isn't it? Remember, this is my first term. This is just 4. So now look at what the sum is. R is still the same, isn't it? A sub 1 over 1 minus R now becomes 4 divided by 1 minus 0.6. Sum's now 10, isn't it? Does that make sense? Think about it. The sum of all the terms starting with n is 1 was 6, but now we've added in an additional term, which was that first term of a sub 0, which was 4. What's 4 plus 6? So it works out, doesn't it? All right. So the last thing I want to talk about is applications of this. One of the big applications that we see for this type of formula when we're talking about an infinite geometric series is something that undergoes a multiplier over and over again. A lot of times that has to do with money, right? Have we seen this before? Yeah, we have, haven't we? Here's one for you. Our final amount is our principal times Remember this formula? This is a sequence, isn't it? Or a series. It's adding up. We're adding over and over and over. We're adding up if we're trying to figure out what's going on here. This is compound interest, isn't it? So compound interest is actually a type of geometric series if we're adding up over and over and over again, which you do. One of the ways we use this is what we call an annuity. Annuity is a type of fund that is indexed, usually off of some sort of a stock market, okay? It's an investment piece where you're guaranteed income. So they sell you this product called an annuity, and you're guaranteed a certain level of, no matter what the stock market does, you're guaranteed a certain level of income. Yes, you are guaranteed a certain level of income. They guarantee you'll make 8%. Now, if the stock market goes above that, company makes money. But if the stock market dips below that, yeah, you still can't ever run out. Even if you run out, company still has to pay, doesn't it? So that's kind of what an annuity is. All right, so if we have an annuity, let's actually look at this. For example, we have we're paying for our annuity, okay? So we're going to do $50 a month. Okay. They're going to give us a guaranteed interest. Probably not going to be very high because, this is a long-term investment. So they're going to say 3% interest. Still better than sticking it in a savings account. Not by much. I will tell you that. Not by much. So we want to know the balance. After 24 months. Two years. All right, the balance is going to be every time we collect interest, isn't it? And then we're going to have to add that to what the balance was before. So we're going to use this compound interest formula, but we're going to be adding it in. We want to know what the total amount is every time. So you can see it's a summation, isn't it? You can see how it kind of ties in here. All right, so let's figure out, we got to figure out what the initial, what? So what is our R? Do we know? All right, remember this is compounding interest. So let's plug into our compound interest formula and set this up. So every time we want to find a sum, we have to take the what? The principal is going to be a $50 payment, isn't it? Our interest rate is 0.03 over, this is monthly, right? So it's over 12. And this is going to be what? 12 times, over 2 years. Don't do 24. It would total up as okay. This would be for A sub 24, wouldn't it? Yes? We don't need a sub 24 though, do we? What do we need for our formula? We want to do for how many months? 24, right? So that's going to be a sub 1 times 1 minus r to the n divided by 1 minus r, isn't it? Yes? So we need r and n and a sub 1. So what's the amount going to be after the first time here? What should this be up here if we're doing a sub, this would be 24 for a sub 24, so a sub 1 would be what? Wouldn't it? We still got to figure out what this is, so how do we figure out what that is? 1 plus 0.03 divided by 12, right? I get 1.0025. So do we know a sub 1? Can we figure out what a sub 1 is? What's the amount going to be after the first month? That's what I got. Is that a sub 1? All right, what's r? Wouldn't that be r? Yeah, 1.0025. And what's n? Yeah, 24 months. So can we fill this in? Yeah, we can, can't we? So let's figure out what S sub 24 is. A sub 1 we said was 50.125. 1 minus to the 24 divided by 1 minus 1.0025. Right? All right, what'd you get? All right, so graphing calculator and summation. Can we use our graphing calculator for summation? The answer to that is yes, you can. So let's look at a summation. You can use it for finite, okay? Can you use it for infinite? No, because yeah, not an infinity symbol, but you can use it for finite. So let's look at a finite one. Let's look at something and see if we can figure out how to put this in. We have n equals 1 to 9 of 2 to the n minus 1. Now, let's do this old-fashioned way, and that way we can use it, because I'm going to want to see your work. Find the sum. So is this finite or infinite? This is finite, isn't it? So we're going to do s to the what? S to the 9th? Would you agree? Whatever's here goes here. So we know that n equals 9. What is r? What's being raised to a power? 2. And how do I find a sub 1? I'd plug in 2 to the 1 minus 1, right? Which is 2 to the 0, which is what? So a sub 1 is 1. So if I want to find s sub 9, I'm going to do a sub 1, 1 minus r to the n power divided by 1 minus r. So figure out what your sum is, and then we'll double check it. What do you get here? 511. Did everybody get 511? Okay, so here's what I want you to do. Hit the math button on your calculator, math. Go down that list, keep going down until you see the word summation. Look what it gives you. Press that button. Now, we had n, but we're going to use x. Doesn't matter if we use x as long as we're... So press X in that first blank. X equals what? 1. And then we're going to arrow up to the top, and we're going to go from 1 to where? And then we're going to arrow over until we're in the parentheses, and we're going to put that equation in. 2 raised to the what? X minus 1. And then we're going to arrow out. Everybody figure it out? Then you're going to press equal. And what do you get? 511. So we know on our calculator it checks out, doesn't it? So can you put this stuff in? Absolutely. As long as it's a finite sum, we can double check the finite sum on our calculator. Did everybody figure out how to use it? Super easy, isn't it? Well, you should be able to double check your work on that. Now, if it's infinite, does that work? Nah, because where's the infinity symbol? You don't have that. You can't go from 0 to whatever. All right. So any questions on geometric sequences or series? That's what we're going to cover for today. Now, I would like for you just to do a few of these here and there. So you're going to do your homework on this, and you can just go ahead and circle finding the nth term. No, let's see. Everybody got that?